Hi everyone, it's Miss Nerd. Welcome to my channel. In today's video, we will be solving IAL Mathematics Jan 2020 M1 paper. So let's start with question 1. Two particles P and Q of mass m1 and m2 respectively are moving on a smooth horizontal plane. The particles are moving towards each other in opposite directions along the same straight line when they collide directly. Immediately before the collision, both particles are moving with speed u, which stands for mass, final velocity v minus initial velocity u. Okay, so as it states on q, so we're going to consider everything for the particle q. So for q, its mass is m2, its final velocity is 1 by 3u minus, now this is a step where students usually, so the first thing for mechanics, always drawing out the question. So let's start. This is there, this is particle P, this is particle Q. They both are traveling towards each other and their masses are m1 and m2. They both have the same initial speed u. Then the direction of motion of each particle is reversed by the collision. So after a while, this is again particle P, this is again particle Q. Their directions are opposite to each other. So it becomes like this, still traveling in this way. And then immediately after the collision, the speed of Q is 1 by 3u. So it's going to be 1 by 3u. And then the first part says, find in terms of m2 and u the magnitude of the impulse exerted by P on Q in the collision. So let's do part A. Okay, impulse has the equation impulse equals to m, which stands for mass, final velocity v minus initial velocity u. So as it states on q, so we're going to consider everything for the particle q. So for q, its mass is m2, its final velocity is 1 by 3u minus, now this is a step where students usually tend to make mistakes. So here, when doing momentum questions, always one side has to be positive and the other side has to be negative. Like if example, you take the right side as positive, the opposite side has to be taken negative. So I usually tend to take to the right as always positive. So anything traveling to the left is going to be taken as negative. So here, the velocity for now q final was to the right, so we have taken 1 by 3u positive, but initially q was traveling to the left, so it's going to be taken negative velocity, so it's going to be negative u. I hope that made sense. And then after simplifying it, m2, 1 by 3u minus minus is going to become plus, so it's going to become 4 by 3u, and this is the final answer, 4 by 3 m2u. There we go, this is part A. And now part B says, find in terms of m1, m2 and u the speed of P immediately after the collision. So let's start part B. So for momentum questions, there is a very common equation which all IGCSE students must have learned in physics. It's m1u1 plus m2u2 equals to m1v1 plus m2v2. So m1u1 is going to be taken for particle P. Particle P has mass m1. It was traveling to the right, and so the velocity is going to be positive. So u plus m2u2 is going to be taken for particle q initially. it was traveling to the left, so it's going to be taken negative. Particle Q has mass m2 and a negative velocity of u. m1v1 is going to be taken for again particle P, and after the collision it was traveling to the left, so it's going to be m1 minus x, we had taken it x, and then plus m2v2 is going to be taken for particle Q again, and its velocity was 1/3u. Okay, and now the only thing to do is m1u minus m2u minus m2 1/3u divided by minus m1 is going to make x the subject. Okay, and now we are going to simplify it. m1u minus 4/3 m2u whole thing over minus m1 is equals to x. Okay, now taking u the subject, it's going to become m1 minus 4/3 m2 whole thing again over m1 is equals to x. Okay, now what we can do is take LCM inside the brackets. That is going to make our life a lot easier. So there is 1 here, right? And so LCM is, I'll multiply 1/3 and m1 into 3. And then what we're going to do is it's going to become u 3m1 minus 4m2 divided by 3 whole thing divided by minus m1 is equals to x. And now this 3 can come down to here because it's a denominator, right? So the final answer is going to be x equals to u 3m1 minus 4m2 whole thing divided by minus 3m1. This is part B. Part C says, hence show that m2 is greater than 3/4 m1. So we are going to use the answer from part B itself for part C. So part C is going to be u 3m1 minus 4m2 whole thing over minus 3m1, right? And this was considered for particle P, right? And particle P was moving to the left. So moving to the left means it has a negative value of velocity, so it is less than 0. And so now if I move minus 3m1 to the right hand side, it's going to remain still as 0. And then again if I move u to the right hand side, it's again going to be 0 because anything multiplied by 0 is 0. So what I have remaining is 3m1 minus 4m2 is less than 0. Minus 4m2 less than, I'm going to move 3m1 to the right hand side, it's going to become negative 3m1. And then I'm going to move minus 4 to the right hand side. Remember always that whenever you are dividing or multiplying by a negative number, the sign is supposed to change. So the sign is going to become like this, minus 3m1 upon minus 4. The negative sign is going to get cancelled and we get our answer 3/4m1. And that's it. Now moving on to question 2. Question 2 states that a non-uniform beam AB has length 6 meter and weight W newtons. The beam is supported in equilibrium in a horizontal position by 2 vertical ropes, one attached to the beam at A and the other attached to the beam at C. where CB is equal to 1.5 meter as shown in figure 1. The center of mass of the beam is 2.625 meters from A. The ropes are modeled as light strings. The beam is modeled as a non-uniform rod. Given that the tension in the rope attached at C is 20 newtons greater than the tension in the rope attached at A. Now again we are going to draw out the stuffs for us to make life easier. So the word non-uniform rod, there is a major difference between uniform rod and non-uniform rod. Uniform rod is the one where weight acts at the center. So example, this is 6 meters, so here around here it's going to be the center. This is going to be 3 meters from A. So the weight is going to act exactly at the center. But for a non-uniform rod, the weight could act here, the weight could act here or here. It could act at anywhere of the rod, okay? So I'll erase this. Now let's draw out the numbers. So the center of mass, which means it's the weight of the beam, is 2.625 meter from A. So I'll take it around here and I'll write it as W, and it acts downwards. This 2.625 meter from A. And now, given that the tension in the rope attached at C is 20 newtons greater than the tension in the rope attached at A. So A, the tension in A, I'll consider it as T, and at C, as they say 20 newtons greater, it's going to be T plus 20. I hope you guys understood. Our question A states that find the value of W. Okay, so for the moment questions, there is one basic equation which everyone needs to know, that is that the total upward forces over here, the upward forces are this T plus 20 and this tension. These are equal to the downward force. The downward force over here is only W. So let's make an equation out of this. I'll start part A here. Part A. So now the total upward forces are T plus 20, which is equal to the downward force, that is W. Simplifying this, we get W equals to 2T plus 20. Alright, this is my first equation. The second equation is moment equals to, everyone probably knows this from IGCSE, force into distance. We are going to follow exactly that. So the total moment clockwise is equal to the total moment anti-clockwise. Now we are going to consider moments about A, because if I use A, then I won't have to consider the tension over here. I just have to consider this tension T plus 20 and the weight acting down. Now if I take A, the weight is acting down. As it's acting down on A, it's going to make it move clockwise. Alright, and this T plus 20 is acting upwards. Now if I consider it A as a pivot and the C is making it move upwards, so it's going to create an anti-clockwise effect on A. With that thing, we're going to follow through our equation. So first, the important step is writing, we are taking moment about which point. We are taking moment about A over here. So first let's consider clockwise movement. The clockwise movement is weight, force times the distance from A, they say 2.625 meter, which is going to be equal to the anti-clockwise movement, that was, the force was T plus 20. And now the distance from here, 6, I need the distance AC. Alright, I can get this by subtracting 6 minus this 1.5, which is equal to 4.5. So this will be multiplied by 4.5. Now we have the duty to just simplify everything out. 2.625W equals to 4.5T plus 90. 20 times 4.5 is 90. Alright. And now we are going to make T the subject. Making T the subject, it's going to be 2.625W minus 90 divided by 4.5. This is my equation 2. I can substitute now this tension. I can substitute this tension over here to find W. Now let's continue here. So W was equals to 2 times T plus 20, right? So the tension equation we found was 2.625W minus 90 over 4.5 plus 20. And W equals to 2 divided by 4.5 is 4 by 9 times 2.625W minus 90 plus 20. Alright. And then W equals to 7 by 6W, because 4 by 9 into 2.625 is 7 by 6. And then 4 by 9 into 90 is 40 plus 20. Simplifying this, taking W to the other side, we get minus 1 by 6W equals to minus 20. The negative signs would be cancelled. W equals to 20 divided by 1 by 6 is 120 newtons. And that is part A. Next, part B states, state how you have used the fact that the beam is modeled as a rod. Beam is, these are some, for mechanics, these are some like questions which have specific answer to them. So for part B, when they ask model as a rod, the answer is beam remains straight. So that's conclusion to question 2. Moving on to question 3. A particle P is projected vertically upwards with speed u from a fixed point O. At the instant when P reaches its greatest height h above O, a second particle Q is projected with speed half u vertically upwards from O. Now again, let's draw this out. It's going to look something like this. Imagine this point is O, okay? And the ball goes up. Particle P is projected upwards with speed u. So this is particle P, okay? It's at its greatest height h. So this part is h, okay? A second particle Q is projected with, this has a speed u, remember? And then a second particle Q is launched with a speed half u. Alright. Find h in terms of u and g. Part A. Here comes the SUVAT equations. I hope you guys know that. We have the velocity. The final velocity for P is going to be v equals to 0, okay? Its initial speed was given to us as u, and the distance it traveled was h. It was at its greatest height h. At the greatest height, remember the velocity, the final velocity at that point is 0. And then when an object moves up, the acceleration is negative g. I hope you guys know. And in mechanics, g is equals to 9.8. So we can use the Suvet equation. V square equals to U square plus 2AS. If we substitute now, my velocity, final velocity was 0. 0 square equals to U square plus 2. Acceleration was minus G. My distance h. Okay. And then now if I make h the equation, minus U square over minus 2G equals to h. If I cancel out the negative signs, we get our answer. H equals to U square over 2G. That's part A. And then part B states that find in terms of U and G the time between the instant when Q is projected and the instant when the two particles collide. Okay, part B is a tricky question, but I will make it easier for you guys. Part B. First, let me draw it up again for you all. Imagine this is P over here and this is Q over here. Alright, Q is moving up, P is moving down. And at some point, P and Q come and collide with each other. They want the instant, they want the time when they collide. At which time do they collide? We know that P is at the greatest height, Q is over here, and this O. And the greatest height is h, okay? What we can do is find the distance here. Alright, put a different color. The distance P travels down and the distance Q travels up is going to be equal to h. So I'm going to consider traveling down as x, going up as y. So we have an equation x plus y equals to h. So now our duty is to find distance x and distance y, again using the Suvet equations. For P, we know that we are finding the distance x, that is a question mark. Our initial velocity is now going to be 0 because traveling down, it's going to travel with a different speed. Now initial point for now is at this point, right? So the initial is going to turn 0 because initially now it was at its greatest distance. Then acceleration, now it's falling down, so we are going to take positive acceleration, positive G, and then T. T, we'll just keep it as T, alright? Now using the equation S equals to ut plus half at square. Now my S is x. My u is initial velocity, which is 0 times t, which is obviously again 0, half, this is g, and t is kept as t. So we get the equation x is equals to half gt square. Alright, we got x. Now for y. Y is going to be, for y, let's note down what we have. Obviously my y is question mark, the distance. Acceleration, now it's traveling up, so it's going to be again a negative g. U is initial velocity. Here they have mentioned in the question. Q is projected with speed half u vertically upwards. Alright. So u, my initial velocity is half u, and again there is t. Here we are going to use again the equation S equals to ut plus half at square. My S is y. My initial velocity was half u times t minus half g t square. Alright, this is there. And now we just have to equate it into h. For x, it was half gt square, and plus y is half ut minus half gt squared is equal to h. We can see that half gt square and here half gt square can be cancelled. Half ut is equals to, we found an equation of h in part A, that is u square over 2g. Now we can substitute this over here. U square over 2g. Alright, so now making t the subject, we get it as u square over 2g divided by 0.5u. So that gives me the answer. T equals to, now this u and u is going to get cancelled, and then 2 and 0.5 is also going to be cancelled. We get the answer u over g. We got the time. That was it, and we scored 6 marks. Okay, so part C, find where the two particles collide. So part C says find where the two particles collide. This part is very easy. Just substitute into either equation of x or either equation of y. Obviously, for easiness and to save time, we are going to follow with x, which is x equals to half gt square. Half g is 9.8 and t square is u upon 9.8. 9.8 and squared, so I'll just write it in much more detail. So 9.8 and this 9.8 can be cancelled. We get 0.5 u squared over 9.8, which can be simplified and written as u squared over 2g. And now we see that u squared over 2g, which is exactly the equation of h which we found at part A. So this tells us that they met, therefore they met at h. Now I think question 3 is over as well. Moving on to question 4. Okay. Two identical small rings A and B, each of mass m, are threaded onto a rough horizontal wire. The rings are attached by a light inextensible string. A particle C of mass 3m is attached to the midpoint of the string. The particle C hangs in equilibrium below the wire with angle BAC beta as shown. The tension in each of the parts AC and BC of the string is T. Okay. First, let's mark out all the forces which we can. So C is of mass 3m. There is going to be weight, and weight equals to mg, right? So the mass is 3m, so it's going to be weight is 3mg. Okay. Now next, these have mass as well, so this is going to be mg. This is going to be mg as well. And they say the tension in each of the parts AC and BC of the string is T. So these are T, alright? These both are T. If this is beta, okay, then an angle from here, this forms an alternate angle. So this must be beta as well. And this angle must also be beta because this is beta, because of alternate angles. I hope you guys understood. And then we are drawing out the vectors of the tension because it's acting at an angle. We draw it like this. Okay. So these are going to act upwards. Okay. And now when drawing out a vector, there is cos and there is sine. The one with which the angle is there, this angle is joined with this one, the down one. So this becomes cos, the force T cos beta. And the other one which is there that is acting upwards is T sine beta. Same goes for here, as this angle is attached with the one below. This is going to be cos T cos beta, and the one acting upwards without angle being attached is T sine beta. So we have all our forces marked up. Now we can proceed with the question. The question says, by considering particle C, find T in terms of mg beta. The forces acting up is being equal to the force acting down. And only considering particle, I write it with a different color, with particle considering C. The only forces acting are the tension and its weight. You can see this tension is acting, and its weight is acting down, right? I'll remove them. Okay, and now the most important thing is, which tension should you consider? Remember that when you are taking forces in the horizontal direction, we would have used T cos beta. But as we're taking weight, which is a vertical force, we have to use the vector that is also vertical, that is sine beta. Okay, we have to use sine beta. I hope you guys understood. And remember that C is in equilibrium position. They have mentioned it. C hangs in equilibrium. So that means the total upward forces acting on C is going to be equal to the total downward forces acting on C. Let's continue. Start with part A. Part A. So for considering particle C, there are two tensions acting. This T sine beta and this T sine beta are both acting on C, right? So we can make the equation T sine beta plus again T sine beta. These are the upward forces. These are equal to 3 mg the weight. So simplifying this, it's going to be 2T sine beta is equals to 3 mg. Making tension T the subject, we get 3 mg by 2 sine beta. That is answer for part A. Now part B says that find in terms of M and G the magnitude of the normal reaction between the wire and A. Now, so at A, as it is attached to something, right, on a rough horizontal wire, this is a wire. So there is going to be a normal reaction force acting vertically upwards on this B as well, okay? And they say to find the magnitude of this R. Now considering A, only A, we can see what are the things acting on A. This T sine beta is acting and its weight is acting and the R is acting. Now again we will use the statement that total upward forces is equal to total downward forces. The upward forces acting on A was R, the reaction force, the T sine beta, the t sine beta, which will be equal to, now you can see that A is threaded with C, so the weight of C. Okay, so it's going to be mg, this is the weight of A, plus 3 mg, the weight of C. So making R the subject, we get 4 mg minus t sine beta. Alright, and then 4 mg. Now because they wanted in terms of m and g only, we have to remove the beta. To remove beta, we found in part A that the equation for t can be written as 3 mg over 2 sine beta. And there is this sine beta left as well. Sine beta, right? So this sine beta and this sine beta can be cancelled out, and we get 4 mg minus 3 by 2 mg. 4 minus 3 by 2, we get 2.5 mg. And that is the answer for part B. Moving on to part C. The coefficient of friction between each ring and the wire is 4 by 5. The two rings A and B are on the point of sliding along the wire towards each other. Find the value of tan B. Okay, so let's continue. As they say, they are on the point of sliding towards each other. The friction is going to act in the opposite direction, because friction always opposes motion. So the friction F is going to act this side and F is going to act this side. Okay, so let's move on. Part C. We know the equation friction F equals to mu R, and mu is the coefficient of friction which they gave as 4 by 5. So 4 by 5 into the normal reaction force we found is 2.5 mg. 2.5 mg. If we simplify this, we get 19.6 m. Okay, this is point A. Okay, it's tending to move to the right. It's tending to move to the right, so the friction is acting to the left. This is the friction. This is the wire with which it is connected to C. This is A. Okay, there is tension acting here. We again have to simplify it into vectors, that is, this was beta, right? And at the horizontal direction, I'll remove this. At the horizontal direction, it's going to be t cos beta. And the vertical direction, it's going to be t sine beta. So now we can see that as A is still in equilibrium position, the friction F is going to be equal to t cos beta. So we can make it out into an equation again. F equals to t cos beta, right? Now we found that F equals to 19.6 m. And t cos beta can be written as 3 mg by 2 sine beta, because we found tension T in part A. 2 sine beta and then cos beta is there. We have to find tan beta, and tan beta is going to be equal to sine by cos, but you can see we have cos by sine. So if we reciprocal, we can get sine by cos, but always remember you have to reciprocal on both sides of the equation. So 1 over 19.6 m is going to be equal to 2 sine beta over 3 mg cos beta. Okay, so this is going to become 1 over 19.6 m is equals to 2 by 3 mg tan beta. Sine by cos is tan. M and M can be cancelled out, and then 1 over 19.6 is equals to 2 by 3g tan beta. Then tan beta is going to be 3 upon 4. That is the answer for part C. Now question 5. Question 5 states that a car travels at a constant speed of 40 meters per second in a straight line along a horizontal racetrack. At time t equals to 0, the car passes a motorcyclist who is at rest. The motorcyclist immediately sets off to catch up with the car. The motorcyclist accelerates at 4 meters per second square for 15 seconds and then accelerates at 1 meter per second square for a further t seconds until he catches up with the car. Sketch on the same axis the speed time graph for the motion of the car and the speed time graph for the motion of the motorcyclist from time t equals to 0 to the instant when the motorcyclist catches up with the car. Okay. So let's begin. First, let's draw out our stuffs. A car travels at constant speed. This is my car, okay? Don't mind the drawing. It's traveling with 40 meters per second. In a straight line along a horizontal racetrack at time t equals to 0, the car passes a motorcyclist who is at rest. So this is a motorcycle. I'll just draw 2 tires then for this, which has 0 meter per second, and this is at time t equals to 0. Okay, now the car at rest, the motorcyclist accelerates at 4 meter per second square for 15 seconds. 4 meter per second squared for 15 seconds, and then for 1 meter per second square for a further t seconds. So 1 meter per second square for a further t seconds. This part is t. Okay, I don't know this until what time does it go. Now sketching it out. Okay, so 40 meters per second for car, it's just a constant. They say to draw a speed time graph, right? So let's sketch it out. Part A is something like this. Okay, this is speed, this is time, and a constant speed for car, it's a constant speed at 40 meters per second. We'll consider this 40. The motorcycle, there's a bit of calculations we have to do. First, we have to find the speed. We have the time taken, that is 15 seconds. We have acceleration, that is 4. We know the equation. Acceleration equals to v minus u by t. Initially, u was 0. So we need only v, the final speed. V equals to acceleration into time. Acceleration was 4. It traveled for 15 seconds. And that gives me 60 meters per second. So let's take around this as 60, okay? So for 15 seconds, it travels up with constant acceleration and then it travels up with further 1 meter per second squared. Again, we can follow the equation. Acceleration equals to v minus u by t. The acceleration was 1. My final velocity is what I don't know, v. Its speed was this time 60 because first it was traveling with 60 meter per second and then it changed, right? So my initial speed was 60 and the time it traveled was t. As they mentioned, they did not give us for how many seconds it traveled with 1 meter per second squared. So making v the subject, we will get v equals to t plus 60. Alright, so somewhere here, I'll erase this bit. Okay, I'll make this a bit longer. Okay, this is v. So imagining this as t plus 60, okay, we can draw it out like this. It will travel, this is t plus 60, okay, so it's going to travel like this, and this traveled, the motorcyclist traveled with 1 meter per second square for t seconds. So it's supposed to be 15 plus t, because it already traveled for 15 seconds and then it traveled for another t seconds, so it's supposed to be 15 plus t. And remember that this has to be, okay, I'll write with different color, this has to be less steeper than this one, all right, because 4 meter per second square is higher than 1 meter per second square, so 4 has to be more steeper than 1 meter per second square. And remember, a very important fact is that this have to end at the same line, all right, the both curves, both for both car and the motorcyclist. Now let's see. Part B says, at the instant when t equals to t1 seconds, the car and the motorcyclist are moving at the same speed. Find the value of t1. So the spot where they're traveling with the same speed is over here. This place, it's moving with the same speed. So for part B, what we're going to do is we're going to use again the Suvat equation. Part B, I'll write with red. So acceleration equals to v minus u over t. Now we can see that our acceleration is 4 meter per second square. We knew it from the motorcyclist, right? So this part, I'll draw it with blue. This part is 4 meter per second square. And the speed was 40 meter per second. So now acceleration was 4. My final velocity was 40. My initial velocity, it was at rest, so it's going to be 0, and this is time t. Moving on, t equals to 40 divided by 4, that is 10. So the answer is at 10 seconds, they travel with the same speed. Moving on to part C. So part C says that show that t square plus kt minus 300 is equals to 0. We can do this by finding the distance under the curves, right? We know that one thing for sure is this part of the curve and this part of the curve has the same distance. So we can make an equation out of that. Part C. Considering first the car, It's a rectangle, so it's length into breadth. So 40 times 15 plus t is going to be the distance for the car. 40 times 15 plus t, which is going to be equal to the area under the curve for the motorcyclists. For the motorcyclists, it's a trapezium, as we can see. For the trapezium, what we can do is we can separate it out. For the motorcyclists, we know this is t. We can find this is a triangle. As you can see, this part is a triangle. So we can use the equation area of a triangle equals to half times base which is 15 times 60 the height, plus considering the trapezium, it's going to be the distance between the parallel sides times the sum of the heights, that is 60 plus t plus 60. Simplifying this, we get 40 times 15, 600 plus 40t, which is equals to 450 plus t by 2 times 120 plus t, and then 600 plus 40t is equal to 450 plus 120 divided by 2 is 60t plus t squared over 2. Simplifying this, we get half t squared. 60t minus 40t gives me 20t. 450 minus 600 gives me minus 150, which will be equals to 0. And now if I divide the whole equation by half, dividing by half, I get t squared. 20 divided by half is 40t. Minus 150 divided by half is minus 300. 0 divided by half is 0. And that is the answer for part C. And part C says that where k is a constant to be found, so here k is equals to 40, because this is k value. Moving on to question 6. Question 6 states that a force F is given by F equals to 10I plus J Newton. A part states find the exact value of the magnitude of F. So A part is pretty simple. So magnitude of F is symbolized like this. Finding magnitude is 10 squared plus 1 squared, which equals to, and they said exact value, so we will just write it in the form of surd root 101. Part A is done. Part B states that find in degrees the size of the angle between the direction of F and the direction of the vector I plus J. Now again, let's draw it out. So my vector was 10I plus J, right? 10I is in the horizontal direction, so this is 10I, and 1J. So 1, let's consider this 1. This is the point, and it's going to look something like this. There's going to be an angle, okay? And the vector I plus J, so it's going to be 1 is somewhere considering here. Draw it with another color. 1 is somewhere here, and 1 is again here. So it's something like this. It has an angle total here. Now first, what we can do to find the difference between the angles is find both the angles. Finding angle is pretty simple. This is basic IGCSE. For the bigger triangle first, let's find out. Using SOHCAHTOA, we can see that this is 10, this is 1, tan theta. TOA. So that is opposite is 1, adjacent is 10. So theta is equals to 5.71 degree. And for the other one, tan theta equals to 1 upon 1. Therefore, theta will be equals to 45 degree. And so the difference between the angles is going to be 45 minus 5.71, which is going to be equals to 39.3 degree. That is the answer to part B. Now part C states that the resultant of the force F and the force minus 15I plus AJ, where A is a constant, is parallel to but in the opposite direction to the vector 2I minus 3J. Find the value of A. Now here the important part is it is parallel and in the opposite direction. So for questions like this, part C, I'll do it here. Part C, in terms of column vector, 10, 1 plus minus 15 A is parallel to but in the opposite direction. When questions like this come out, they are a constant multiple of each other. So make sure to write K, and then it is parallel to but in the opposite directions, right? To the vector 2I minus 3J, but as it is in opposite direction, their signs are going to reverse. Instead of 2, it's going to be minus 2. Instead of minus 3, it's going to be 3. Simplifying this, we can come out to an answer. Writing all I terms together, okay? 10 minus 15 is going to be equal to minus 2k. Simplifying this, we can get k equals to 5 by 2. And then the second equation is going to be 1 plus a is equals to 3k. We found the value of k to be 5 upon 2. Simplifying this as well, we will get 15 by 2 minus 1, which is 6.5. That is the answer for part C, and we're done with question 6 as well. Coming up to the last question of the paper. Question 7 states that a particle A of mass 4 kg is held at rest on a rough horizontal table. Particle A is attached to one end of a string that passes over a pulley P. The pulley is fixed at the edge of the table. The other end of the string is attached to a particle B of mass 3 kg, which hangs freely below P. The part of the string from A to P is perpendicular to the edge of the table, and A, P, and B all lie in the same vertical plane. The string is modeled as being light and inextensible, and the pulley is modeled as being small, smooth, and light. The system is released from rest with the string taut. At the instant of release, A is 2 meters from the edge of the table and B is 1.4 meters above a horizontal floor as shown in figure 3. After descending with constant acceleration for 2 seconds, B hits the floor and does not rebound. So let's draw again the stuffs which we need. There is going to be a tension acting T. There is going to be a tension acting T. There is weight of ball B, that is going to be 3G. There is going to be weight of A acting down 4G. There is going to be a reaction force R. Now, part A states that show that the acceleration of A before B hits the floor is 0.7. Acceleration of A. Okay, so we have to understand the fact that as ball B is falling down with an acceleration, the same acceleration will be applied to A. As B is falling down, A is also moving towards the pulley. So if B is falling down, example, with 3 meter per second squared, then A as well is moving towards the pulley with 3 meter per second squared. So now you can see that for A we don't have that much data provided, but for B we have. We can use the Suvet equations to find the acceleration of B, which will also be equal to the acceleration of ball A. So using Suvet equations, we can see what all data we have provided. The initial velocity of ball B is 0 because it was at rest in the beginning. The acceleration is what we are searching for, and the distance between the ground and the ball was 1.4, so that means it travels the distance 1.4 meter, and it travels that distance within 2 seconds. So we are going to use the equation S equals to ut plus half at squared. My S is going to be 1.4, U is 0 times 2, which is again 0, plus half a 2 square is 4. Okay, so 1.4 is equals to 2a. Therefore, a equals to 0.7 meter per second squared. Now, part B states that state which of the modeling assumptions you have used in order to answer part A. That is, we have assumed that this is an assumption. We made the assumption that ball A and ball B have same acceleration. So A and B have same acceleration due to inextensibility of string. Okay, now part C. Part C states that find the magnitude of the resultant force exerted on the pulley by the string. Now this question is very common, so make sure you learn it well. The pulley is acting here, right? This is pulley P. A tension force is acting this side, a tension force is acting this side, all right? So as these are horizontal and vertical but not in the same plane, like horizontal and horizontal, if they were two horizontal forces or two vertical forces acting on the pulley P, we could have simply added them, but as they are acting in different planes, we have to find the resultant between them, that is this. That is going to be equal to the force acting on pulley P. So first we need to find the tension T, and for finding tension T we can make equations. Considering ball B again, okay, now you can see that I can make out equations from here. As the ball B is falling down, this proves us that the weight is greater than the tension, and we know the equation resultant force equals to MA. Resultant force of ball B will be weight minus the tension. Because weight is greater, that's why weight will be in the front. So which will be equal to 3 times the acceleration we found 0.7, right? So now let's follow through. I don't have space here, so we'll go back to the place. Here, part C. So we say that weight minus the tension is going to be equal to MA. So the weight was 3G minus the tension, which we are searching for, and the mass was 3, and the acceleration we found in part A was 0.7. Simplifying this, we get the tension is equal to 27.3 Newton. Now, to find resultant force acting on the pulley, we are going to do F equals to root 27.3 squared plus 27.3 squared, which is equal to 38.6 Newton. Well, the part D states that the coefficient of friction between A and the table is mu. Find the value of mu. As it's related to table, now we will consider the particle A. Now considering particle A, as there is tension and A is initially in equilibrium position, so the friction must be acting opposing it, so to the left. As ball B falls down, that proves us that the tension is greater than the friction provided. So we can create out again equation, which is resultant force equals to MA, that is tension minus the friction will be equal to MA. Alright, so we will continue with this down. Okay. Part D. So for A, tension minus friction is equals to MA. The tension we found was equal to 27.3 and the friction is unknown. We know the mass of ball A is 4 and the acceleration with which it traveled was 0.7. So we can find that simplifying this, friction is equal to 24.5 Newton. Now another thing to be noted is the R here. Now we know that friction is equals to mu R, and this R here, initially the ball was at rest, vertically the ball is at rest, so R must be equal to the weight of the ball A. It's going to be like R is going to be equal to 4G. We know that R is equals to 4G. As F equals to mu R, that means 4G mu is equals to 24.5, and mu equals to 24.5 divided by 4 times 9.8 is 39.2, which is going to give me the answer 0.625, and that is the answer for part D. Moving on to the last question. Determine by calculation whether or not A reaches the pulley. Remember, this is another common question that comes always related to pulleys. Okay, I'll remove all this stuff. Remember that as B falls down 1.4 meter, the same distance will be traveled by A as well. This is traveling by 1.4. So A is also going to travel, this is 2 meters, right? So A is also going to travel 1.4 meter, but there is a difference. As B falls down and reaches the ground, the A is going to travel an extra jerk distance after ball B has reached the ground. This small distance is what we need to calculate. So now let's continue. Part E. First, let's find the velocity with which ball B falls down. We are going to find that using Suvat equations again. It travels 1.4 meter. Its velocity is what we are searching for. It was initially kept at rest and we knew the acceleration is 0.7. Using the equation v square equals to u square plus 2as. Here v is question mark. My final velocity is 0 squared plus 2 times 0.7 times 1.4. The whole thing root. So v is going to be 1.4 meter per second. We found the velocity, and now another thing which we have to know is that after ball B has fallen down, the tension in the rope becomes 0 because the rope becomes slack. There is no more tension left. As tension is 0, then we will get a new acceleration. So we have to find now this acceleration. Going down again to find the new acceleration. So for ball A, we knew that tension minus the friction, which we found was 24.5 Newton, is equals to m times A. Now this acceleration is what we need. The tension becomes 0. Make sure to do this step because this step is where the students usually tend to do mistakes. 24.5 equals to 4a. And then I get the acceleration minus 49 over 8 meter per second squared. Now again, using the Suvat equations, we have the velocity, we have the new acceleration, we can find the jerk distance that it traveled. So I know that it was traveling with 1.4 meter per second and its acceleration was minus 49 over 8 meter per second squared. The distance is what I'm searching for, and after traveling the velocity will become 0 because the ball A is going to stop. Again, using the equation v square equals to u square plus 2as, we can find s now. So v is 0. 0 squared is 0. Then 1.4 squared minus 2 times 49 over 8 times s. Simplifying this, we can find that s is equals to 0.16 meter. So the total distance traveled by A is going to be the 1.4 meter that it traveled at the beginning, which is equal to the distance ball B travels while falling down, that plus the 0.16, which is the jerk distance, that is equal to 1.56 meter, which is yet smaller than 2 meter, which is the distance between ball A and the pulley, as 1.56. Remember, statement has 1 mark according to the mark scheme. So 1.56 is less than 2 meter, therefore doesn't reach pulley. And now that was the end of the paper, guys. If you found the video helpful, don't forget to like, subscribe and hit the bell icon for notifications on my latest videos. Thanks for watching.